I can blow up the balloon with a couple of deep breaths. Now that the balloon is blown up, comes the fun part. Can you change the size of this balloon simply by changing its environment? What do you think would happen if I put this balloon in a freezer? The main difference between the kitchen and the freezer is the temperature. Temperature is the measure of how hot or how cold something is. What is actually being measured is the average kinetic energy of the particles in an object, which depends on how fast the particles are moving. When the temperature of an object increases, the particles in the object move faster. In this case, I will be changing the temperature of the air particles that I blew into the balloon. So right now, the balloon is approximately 24 degrees Celsius, which is the temperature here in the kitchen. Now that the balloon is in the freezer, we'll watch over a period of time to see what happens. The temperature of the freezer sits at negative 18 degrees Celsius. What happens when I leave the balloon here for an hour? Okay, it's been about 1 hour. The balloon is much smaller. So what happened? The particles that make up a substance are always moving. They have a certain amount of kinetic energy called thermal energy. When a substance is cold, its particles move more slowly and have less kinetic energy than when the substance is hot. A cold object therefore has less thermal energy. That's easy to observe if the substance is a gas. At room temperature, the gas particles in the balloon were moving fast and bouncing against the inside surface of the balloon, keeping the balloon stretched. When I placed the balloon in the freezer, its temperature decreased. The gas in the balloon got cold, which means that its particles slowed down. They're not hitting the walls of the balloon as hard as they did before, and the balloon shrinks. Does anyone want to guess what happens if I take the balloon out of the freezer and place it somewhere warmer? Here's a good spot, right next to this warm lamp. I'll leave the balloon here for a little bit and see what happens. Okay, it's been 1 hour and look at the balloon now. It's back to its original size and possibly a little larger. So what happened this time around? The lamp warmed up the balloon. With the rising temperature, increasing thermal energy causes the air molecules in the balloon to move faster. That faster movement means they are pushing harder on the walls of the balloon and the balloon increases in size. So the amount of gas in the balloon did not change. The same particles were there the whole time. The change in temperature caused the air particles in the balloon to behave differently, losing kinetic energy in the freezer and gaining kinetic energy by the lamp. The kinetic energy that the particles have at any given time, whether warmer or colder, is known as thermal energy.